Hi everyone, welcome to my new video. In this video, we will learn about geometric sequence. Now, what is a geometric sequence? Also known as GP. GP stands for geometric progression. Okay, so geometric sequence or geometric progression. Now, look at example number 1. We have a sequence 2, 6, 18, 54 and 162. If you look at these numbers carefully, you will observe a pattern. If you multiply 2 by 3, you will get 6. If you multiply 6 by 3, you will get 18. If you multiply 18 by 3, you will get 54. If you multiply 54 by 3, you will get 162. So, between every two terms, you are getting a multiple of 3, right? If you multiply 2 with 3, you will get the next term, okay? So, that means if you multiply any term with 3, you are getting the next term. So, this is a geometric sequence or geometric progression or GP. Why? Because the multiple is the same between any two terms. Now look at the next sequence. First number is 243, second is 81. Again, if you observe, you divide 243 by 3, you will get 81. If you divide 81 by 3, you will get 27. If you observe 27 by 3, you will get 9. Similarly, if you divide 9 by 3, you will get 3. So again, to obtain the next term, you are dividing the previous term by 3 in every case. That means this is also a GP. Okay. Look at the next case. If you divide 4 by -2, you will get -2. If you divide -2 by -2, you will get 1. If you divide 1 by -2, you will get -1 over 2. If you divide -1 over 2 by -2, then you will get -1 over 4. So, this is also a GP because this number is same. So, you can multiply or you can divide with any number to get the next number. Okay. So, if the number is not changing, if the number is same in each case, then that sequence becomes a GP. Now, let's consider only one example. My first example is 2, 6, 18, 54 and 162. What is the first term? First term is 2, second term is 6. Now when you divide second term by first term, you get 6 over 2, which is 3. Now this 3 is called common ratio, which is denoted as R. Okay. So if R is same in each case, again look at the third term and the second term. A3 divided by A2 is 18 divided by 6, which is again 3. Right. So if R is same between any two terms, then that sequence becomes a GP, and that number is called common ratio or R. Look at another example. Look at question number 1. In this question, we have to check which of these sequence is a GP. Okay. So to check any sequence, we need to find R, which is the common ratio. Now first find R using second term and the first term. You will get 4 over 8, which is 1 over 2. Now again find R using the third term and the second term, which is 1 over 4. Now, when you find R using the first and the second term, you get 1 over 2. But when you find R using the second term and the third term, you get 1 over 4. Now, these two are not same. So that means this sequence is not a GP. Okay. Let's check the second sequence. Find R using A2 and A1. 6 over 9, which is 2 over 3. Again, find R using A3 and A2. 4 over 6, which is 2 over 3. Now, these two are 2 over 3 and 2 over 3. They are equal. They are same. That means this sequence is a GP. Okay. Check the third sequence. X square, x raised to power 5, x raised to power 3, again x square. Again, in my third sequence, first R, which I got using the second term and the first term, is x square, and the next R, which I found using the third term and the second term, is also x square. Both these R's are same. That means this is also a GP. Okay. So like this, we can check whether the given sequence is a GP or not a GP. Now, after checking whether a sequence is a GP or not, next comes how to find any specific term in a GP. Suppose I need to find a 5th term or a 10th term or 15th term in a GP. I can find any specific term using this formula. What is the formula? AN, which is the nth term, okay, nth term, AN, is equal to A is the first term, A times R raised to power n minus 1. R is the common ratio. Okay, so if I have the first term and I have the common ratio, I can find any term in a given sequence. Look at this sequence. The first term of the sequence is 2, second term is 5. I need to find the 5th term. So what is A1? A1 is 2. What is A2? A2 is 5. Calculate R. R will be A2 divided by A1, which is 5 over 2. Now, use this formula. AN is A R raised to power n minus 1. Now, what is n? I have to find the 5th term. That means I have to find A5. A5 is A. What is A? 2 times R is 5 over 2 raised to power n minus 1. N is 5. So this will be 2 times 5 over 2 raised to power 4. If you want to open this, you can write this as cancel 2. You will get 625 over 8. So this is my 5th term. Like this, using this formula, you can calculate any given term. Look at the second example. In this question, you have to find the number of terms. That means you have to find the value of n. Okay. Look at the first sequence. 2, 4, 8 up to 128. What is the first term? First term is 2. Second term is 4. So first I will calculate our A2 over A1, which is 4 over 2, which is 2. Now, the last term is also given in the sequence. So this is my last term, also called nth term, which is an. So an is also given, which is 128. Use these values, put all these values in the formula and calculate n. My formula is a r raised to power n minus 1. Simply put all the values. 128 is 2 times 2 raised to power n minus 1, right? This will be, I will take this 2 on the other side. This will become 128 over 2 is 2 raised to power n minus 1. This will be 64. So 64 is 2 raised to power n minus 1. Now this side I have 2 raised to power n minus 1. On the left side, I have to change 64 into 2 raised to power something. So 2 raised to power 6 is 64. So I can write 64 as 2 raised to power 6 is equal to 2 raised to power n minus 1. Now on the left side and on the right side, my bases are same. Okay. On the left side, I have 2 raised to power 6. On the right side, I have 2 raised to power n minus 1. Now both these sides are equal and they have same bases. That means the powers are also equal. So I can write 6 is equal to n minus 1 or n is equal to 6 plus 1, which is 7. So for the first question, my n is 7. Now similarly, I will use the same logic and the same formula to calculate n. In the second question, a1 is 1 over 2, a2 is 1 over 4. Find r. R is a2 over a1, which is 1 over 4 over 1 over 2. This you can write as 1 over 4. Change divide to multiply times. If I change divide to multiply, I will write 1 over 2 as 2 over 1. Okay. So that means this will be 1 over 2. So my R is 1 over 2. In this case also, the last term is given. Last term is an, which is the nth term. So use the last term. An is 1 over 64. Now I will again put all the values in the formula to calculate n. R raised to power n minus 1. 1 over 64 is a is 1 over 2. R is also 1 over 2 raised to power n minus 1. Now, there are many ways to solve this expression. Suppose I will not take this 1 over 2 on the left side, because I know this is also 1 over 2 and this is also 1 over 2. So I can combine and write this as 1. See, this is 1 over 2 times 1 over 2 raised to power n minus 1. I can write this as 1 over 2 raised to power 1. Then I can combine both the bases together. So this will become 1 over 2 raised to power 1 multiplied by 1 over 2 raised to power n minus 1. So if I combine this together, if I club these two together, this will be 1 over 2 raised to power 1 plus n minus 1. So 1 and 1 cancel. This will be 1 over 64 is 1 over 2 raised to power n. Now on the right side I have 1 over 2 raised to power n. On the left side I have 1 over 64. Both the sides are equal. So I can change my 64 as 1 over 2 raised to power 6. is equal to 1 over 2 raised to power n. Now both the sides are equal, both the bases are equal. That means the powers are also equal. So n is equal to 6. So in the second question, my n is 6. Like this, using the same formula an, you can calculate the value of n. Look at question number 3. Question number 3 is determine the general term. Now, general term is an. Okay. So the question is find an. The sequence is 8, 16, 32, 64. Now, a1 is 8, a2 is 16. What is r? R is a2 divided by a1, which is 16 over 8, which is equal to 2. Now, use the formula an, a r raised to power n minus 1. I have to find the general term. General term is an. So, an is 8, 2 raised to power n minus 1. This will be 8 times 2 raised to power n, 2 raised to power minus 1, right? Simplify this more. I can take this 2 down because 2 raised to power minus 1. So this will be 4. 4 times 2 raised to power n, or 2 squared times 2 raised to power n, or 2 raised to power n plus 2. So 2 raised to power n plus 2 is my general term for this given sequence. Look at another example. The question says, given that the fifth term is 93 and the common ratio is 2, I have to find the first term. Okay, so first write down all the given things. The question says fifth term is 93 and r is 2. Find the first term. Okay, now I know a5 is 93 because it is given in the question and common ratio is 2. How am I going to find the first term, which is a? I will use the general term formula, which is an is a r raised to power n minus 1. Now, in this case, fifth term is given. So, I will write the same formula for a5. That means replace n with 5. A r raised to power 5 minus 1. Okay. Now, what is a5? Fifth term is 93. What is the first term? I have to find the first term. So, I will write it as a. Now, what is r? R is 2. 5 minus 1 is 4. This comes out to be 93 is equal to a times 2 raised to power 4 is 16. Or I can say a is 93 over 16. Okay. So, if any term is given and the common ratio is given, I can find the first term using the general term formula. Now, my next question is find the number of terms of this particular given GP. Okay. The given GP is 248 up to 256. That means first term is given as 2, second term is 4, r is a2 over a1, which is 4 over 2, which is 2, and the last term is also given, which is the nth term, an. an is 256. Now, find the value of n. Use the general term formula. an is a r raised to power n minus 1. Put all the given values in the formula and find the value of n. I can move this 2 down to the other side. Cancel this. 128. 128 is equal to 2 raised to power n minus 1. Now, both the sides are equal. On the right side, I have 2 raised to power n minus 1. So, on the left side, you can change this 128 and write this as 2 raised to power something. Okay. So, 128 is 2 raised to power 7. 2 raised to power 7 is 128. Now, both the sides are equal. Bases are same. That means powers are also equal. That means 7 is equal to n minus 1 or n is 7 plus 1 which is equal to 8. Thank you for watching my video. Please share, like and subscribe to my channel.